Hello and welcome back to Introduction to Astronomy. My name is Paul Eric and I teach physics and astronomy at Ozarks Technical Community College in Springfield, Missouri. This is a set of videos that I've made for my Introduction to Astronomy students. And so if you are one of my students, it is now time to take your Unit 3 exam. So this series of videos is going to be a review of Lesson 15 on the Sun, Lesson number 16 on properties of stars, Lesson number 17 on the birth of stars, and then Lesson number 18 on the deaths of stars. So if you are tuning in and you want to learn something new, well, you're out of luck. So this is just a review of some of my previous lessons. So if you are just tuning in for the regular lessons, then just wait, and so lesson number 19 is going to be coming up, and so you can watch that one. Alright, so I assume that the rest of you are my students now that are watching this, and we want to do a review of lesson number 15, our star. So in your textbook, you're going to want to read chapter 11. Okay, and the first thing that's going to be on the exam is going to be this formula. This is called the ideal gas law, and it relates the pressure of a gas, P, to the volume of the gas, V, to the number of molecules of gas, that's N, and then T is the temperature of the gas, and then K is a fundamental constant of nature called the Boltzmann constant, which you do not need to worry about. So what you should know for the exam, though, is how does this formula work? So we're going to simplify the formula here and just say that it's pressure times volume is proportional to the temperature. And so the questions on the exam might be, if I increase the pressure, but I don't do anything to the volume, what has to happen to the temperature? And so in order to answer this, you should remember that whatever you do to one side of an equation, you do to the other side. So that if this side gets big, then this side has to get big. We could even do it with numbers. So we could say if this pressure becomes 3 times bigger, then this temperature has to become 3 times bigger. The other kind of question that you should be able to answer would be, let's say that the pressure goes up, but we want to know what's going to happen to the volume if the temperature stays like it was before. So the temperature is the same, the pressure has gone up, and we want to know what's going to happen to the volume. Now in order to solve this one, you got to remember that 4 times 1 is equal to 4, but 1 times 4 is equal to 4. So notice that if one number gets big, the other number gets small in order to compensate. So this number got big, so this number has to get small. And again, we could even put numbers to it. So what's the point of knowing the ideal gas law? It's because that the sun is made of gases. And so the sun is going to obey this particular thing. The deeper you go inside the sun, the greater the pressure is going to be. The greater the pressure is going to be, the hotter the temperature is going to be inside the sun. So here's a sample question that would utilize this formula. And then here's a picture that shows the inside of the Earth, the inside of Jupiter, the inside of the sun. And you will notice that the deeper you go, the greater the pressure gets, and also the greater the temperature gets. I also wanted you to see just how small the Earth is in comparison to Jupiter and then just how small Jupiter is in comparison to the Sun. All right, let's take a break. When we come back, let's talk about nuclear physics.